Okay, there's Tar Baby running with one LED in the load position and no Zener diode. Alright, and there are the zero baselines of the current viewing resistor and the battery voltage. The current viewing resistor is being shown at 100 millivolts per division, no attenuation. The battery is being shown at 20 volts per division with a 10x attenuated probe. Okay, so this is the current viewing resistor, 100 millivolts per division, and that's where the zero line is. This is the battery trace at 20 volts per division, and that's where the zero line is. So we're running with one LED, and I've got this LED marked. So the anode is marked with that black plus, and you can see in the load there I've got the positive and negative polarities of the load marked. So if I put this LED in the proper way around with the anode towards the plus and the pins in the hole, the LED comes on, and I get the, turn the channel on, and set the trigger. And I get this wild waveform, don't I? Okay, so there's our waveform with one LED. You can see we have that negative going lump there, and we have this strong negative going lump on the current trace. Right. Okay, so that's with one LED, and now what I'm going to do is just take that LED out and turn it around like this, and put it back in there. Okay, and it doesn't glow. I got it in the right holes. And there's no glow from that LED, right? And there's also no trace on the oscilloscope. Right? You see the battery voltage is indicated there, but there's no current flowing. Okay, so now just take that out and turn it back around. That shows that the circuit's still working. Okay, so now what I have over here is a back-to-back pair of LEDs. And again, I've got the anodes marked. There's another big black plus on the back side of this one. And so I've got a DC power supply. And so what I'm going to do is just show that it is a back-to-back pair. Alright. Okay, so there's your back-to-back pair of LEDs. Alright. So now I'm going to take those LEDs. I'm going to take those LEDs and I'm going to put them in here. Get in there. Socket's about worn out. Alright, now I guess you can see, can you see? Both those LEDs are glowing. One of them is quite a bit brighter than the other one. Actually, the one that's in the correct orientation with the anode on this side is the one that's glowing the brightest. And no, that's not just residual glow. It really is, this one really is on. I'm going to take a piece of opaque paper and stick it in there. You can see that it's really on. right? And if I take this and turn it around, put it in there. Again, the one that's in the correct polarity orientation is glowing more brightly, but the other one, the one that's in backwards, socket is just an IC socket. It's worn out from all the plugging and unplugging that I've been doing. Okay, so they're both glowing. If I take it and turn it around and plug it in, again, they're both glowing. Opaque paper. You see that one is glowing. Okay. All right, so they're both glowing, and the oscilloscope trace continues to show. If I can get it clean. The oscilloscope trace continues to show. The negative bump has gone on the battery trace, but there's this strong negative current here shown on the current viewing resistor. And this will give a strong negative power product, and both LEDs are lighting up. And I think that should show that, you know, both LEDs are lighting up. Thank you for watching.